So a couple of days ago I uploaded a video about testing vintage capacitors for leakage using a simple multimeter on DC volts mode. In the end of the video I mentioned a test that you could do with a meter like this that has the capacitance test, and today that's what I'm going to show you, how capacitance test can also check for leakage. But first I'm going to talk about a little bit about the theory behind the first test that I did on the previous video. So here is a schematic of what I've done. We have mains coming in to 120 volts, and here is the representation of the sine wave. Today I measured here 228 volts, which sometimes varies a little bit, and 220 volts AC goes directly to the meter, and on the other side it goes to a diode which chops one side, it chops the negative side of the wave and leaves only pulsating DC. DC cannot pass through the capacitor, so the reading on the meter should read 0 volts theoretically. And here we got how our DC or pulsating DC looks like. With this diode over here, different diodes will have slightly different voltage drops, but with this one I measured 107 volts. This is not peak to peak, this is an average value, so peak to peak we have 228 volts. So it's a pretty good stress test for this capacitor. If this capacitor is not leaky, the meter will read a certain voltage, and then as it charges up and then immediately drops down to 0. If it keeps reading something like 20 volts, 80 volts, 100 volts, it's leaky or shorted. If it drops right to 0, capacitor is good. So let's test these 4 ones. We got here a brand new one. It's a 22 nanofarads, brand new Chinese yellow capacitor. We have this guy, it's a 47 nanofarads, and I believe it's marginally leaky, still usable but marginally leaky. This was right next to a vertical output too. It took quite a lot of heat in its trash. It's a 1000 volts capacitor, but I believe it's leaking badly. This one is the same from the previous video, which is also trash. We'll test them all in capacitance mode, and I'll show you how to see if they're leaky or not, and then we will retest them using this method here, just to prove that the multimeter capacitance test is reliable. So first thing, select capacitance mode. On this meter, to read accurately small values, we need to click this button right here. Got our Chino capacitor plugged in to one lead. This is not a 22 nanofarads like I said, it's 1.5. That was my mistake, I'm sorry. 1.5 nanofarads. Let's see what the meter has to say about that. 1.5, right on. It's a 10% capacitor, I think. No, 5%. It's reading pretty close to the marked value. This tells me the capacitor is good. Now we're going to remove it, and we're going to test this bomb, the brown third, WIM third capacitor. It's a 50 nanofarad part and 50 nanofarad. It's reading 78. so garbage. Next on the list is the vertical output burnt capacitor. It's a 22 nanofarads and the meter says 42, almost twice the value. Trash, garbage. Next one is the German aeroid capacitor. It's a 47 nanofarad and this one reads 62. It's a bit leaky, but marginally leaky, I would say. Now, to see, I would replace it anyways. Now, to see if the meter is right, we're going to do this leakage test. This is a real leakage test with high voltage, and we're going to test all of these just to prove my point. Alright, now I got the yellow China capacitor plugged in. I have everything connected to the mains, and I'm going to do this live and try to stay alive. We're going to DC volts, manual range, 0.9. So this capacitor passes the test. It may still hold a charge. Don't touch it until you discharge it. Now let's test the brown third. It's supposed to be extremely leaky. There you go. About 60 volts of leakage. It's creeping down a bit. Now it's creeping up. Garbage. 50 volts leakage. Remember that this is a 1000 volt rated capacitor. It's so leaky that I bet it will not hold a charge. Let's try. Nope, nothing. Now the cremated vertical output toasted capacitor. It's even worse. Little bit jumpy. Garbage. Think I can touch this? Yes, I do. Now the marginal guy. It's leaking a bit, but it should creep down to an acceptable value. See? But it's too slow. It should charge faster. So I wouldn't use it on any radio or TV that I care for, but it should work without any sort of major problem. So there you go.